Uh, Welcome to your. Today we saw the topics like multi-level optimization technique in Cmos. Mm, Before that, we learned some basics uh, by starting the techniques. See that in literals, you know that literals, which means that in a equation that like in a equation state, like see that if we can count the how many literals in there are placed, like 1 2 3 4 5 6 7 8 9 10. There's total 10 literals based on the terms which are present in the equation. These are called literals, and based on the literals, if literals is in these literals, next step we convert into the multi-level representations. In this representation, the main goal is to reduce the levels of the gates. See that for example, you take this equation a plus b c plus d plus like c e, and this is the called the sum of product. You notice that, so it has contains 6 literals, and see that we just make it through the equations like gate, simple circuit design, logical design. See like our purpose is to reduce the level of the for the Cmos design. So here we use like the condition was a plus b dot c plus d dot ce. So here we just written like that the gate circuit by the state. Then after, now you see that the level from this from total 3 levels are present from the above equation. This is 1, this is 2, this is 3. See that the equation is this is the equation. It contains total 6 literals and the 3 states. By these 3 stages, by the various factor, we just reduce into 2 or 1. It will make into the size of Cmos will be reduced and also cost effective. And then the transformation technique. This is called the Boolean logical network transformation. See, in transformation there are so many techniques, but the main techniques of which we are discussing here. First one, the elimination. The elimination, which means that you just eliminates the term which are same in the both like house, like in both vertex. Vertex means like that. See, this is one vertex, this is vertex, this is vertex. These are called vertex. And see in the vertex, see this q is equal to a plus p plus bc. This q is called as local variable. This q is called the label, and the a plus p plus bc, these are the local variable. And see that so this is the one state we taken for understanding. So the elimination, which means to remove the vertex from the graph and replace it into equivalent network with a corresponding local function. It's so simple that we just neglect some path which is both in the which term is present in the both side. That's a condition. So see that in this equation we just taken here, and see that by c equal p equal to bc, and same as here also present there. So what we taken is just we put it on the condition here, just see mention the like that, then the time on reduced. So before that, this contains total 8 literals. Now it reduced, like here also 8 literals only, but there's no changes in this. But what happen is, in future we get in after transformation we get some space over in that's the only reason we just doing the elimination. In elimination the literals are not reduced simultaneously in some case, but it will help us to make some free space for the CMOS circuit design after the final transformation. This is one technique.